moment about y 123.4. At point D is 1160.4. 1160.4. I think I got the first one wrong. It's 1243.4. 12. And then at point E is equal to 580.2. Okay. Then moment about Z 186.4. So you have 186.4. Then you have what? You have 372.8. And then at point E is 559.2, or you take 559.6, is not going to be a like big difference. 559.2. Okay. So the third column, you do this, okay? You're going to do your my squared plus by mz squared plus by tx squared, right? So this is 0, this is 0. So 1243.4 squared plus by 186.4 squared plus by 397.9 squared. Then the whole thing square root is 1319. Okay, I get 13. Okay, I get 1318.8. Let me do it again. 1243.4 squared plus by 186.4 squared plus by 397.9 squared. 1318.8. Next is 1160.4 squared plus by 372.8 squared plus by 596.8 squared, square root 1357. Okay, so the next one is 1357. Talking about this, in fact, there are commercial software doing this. Okay, I know some of you, so why not we use the commercial software? Some companies won't buy commercial software because it's too expensive. Okay, so that's where they hire McMaster Gadget 1002.7. Okay, so if you look at these numbers now, let me do it again. 580.2 squared plus by 559.2 squared plus by 596.8 squared. 1102. Okay, so if you look at these numbers, okay, you pick the highest one. Okay, you select the highest. Okay, why you select highest? Because at this point is where point D is where failure will occur. Okay, so that's where it's so critical to find the forces in the right direction. If your forces are wrong, all this is down the toilet bowl, unfortunately. Okay, so now we know it's 1357. Okay, so we use, finally we come to a diagram, or we come to an equation which I will copy and paste. Okay, so this equation is what we're going to use. All right, so we're going to use this expression over here. As I say, the formula is simple. Okay, it is the finding the right values. So C is equal to 2 over pi, and then we are going to square root of 13. What was it? Is it 1357? Yeah, 1357. Oh no, I think the whole thing is just what did the 1357 is already, yeah, it's already square root already. So this is just 1357. Then divide by 50. times 10 to the power 6, and then you do a cube root. Okay, so this will be equal to 1357 times 2 divided by pi divided by 50 power 6, cube root of the answer. Wait. Cube root, cube root of bracket 2 times by 1357 divided by shift pi divided by 50 power 6 is equal to 25.852 times 10 to the power 3 minus 3, sorry, meters. Okay, so the diameter or the minimum diameter is equal to twice multiplied by 25.852 times by 10 to the power minus 3. Okay, so twice times by 25.852 power minus 3 is equal to 51.704. Okay, 51 times 10 to the power minus 3 meters. So this is what you will use, okay, for the minimum diameter. So just to quickly recall back, right? Based on this formula, as I say, okay, finding the right moment in the Y and Z in your torque is the most difficult one. Sorry, it's not the most difficult, it's challenging. Okay, so this is how you get the torque, right? Getting the right moment. But more critical is this. Okay, the most critical is this. The direction of the forces. Once you get the direction wrong, everything is just, it is just your sizing will be wrong. Okay, so that's why I told you, right, there are commercial software just to do this. Okay, just to do this. But again, as engineers, we cannot just trust the black box. Okay, we have to more or less learn how does the black box work like this. Okay, right. So that is all I'm going to do for the design of transmission shaft. Okay, so as I said, uh, in the faculty of engineering, only we do it. Okay, and we have to do it well. Okay, so this should be your bread and butter. Okay, if you're in a company, someone need to calculate the stresses on a shaft, who do they call? Not Ghostbuster. Okay, they're gonna call you. Okay, right. So the next one, I mean, yeah, civil engineers, they don't do a lot of this at all. So the next thing I'm going to briefly talk about the theory. Okay, about principal stresses in beams. Okay, so briefly only what I'm going to teach from now on will not come out in quiz number, I think we're on quiz number 8. Okay, quiz number 8 is on shaft design. Okay, quiz number 9 probably you'll get some of this. Wow, it's so fast. 7, 8, yeah. So we are going to look into I'm going to like draw a line across so that you know that this is a new section. So we are going to talk about principal stresses. Okay, in beams under combined loading. Okay, under combined loading. So again, I'm going to take the image down here. Yeah. So this is the beam, and then I'm going to take the cross section or information regarding the beam. Okay. So for this, I'm going to teach based on an example. Okay. So we're going to find. Okay, we're going to find the maximum principal stresses acting on the beam. Okay, and the section selected. So this is a full stop. The section selected was W250, okay, times by 28.4 white shade. Okay, so this is as real as it comes. Okay, in terms of stress analysis, right? So some of you might say, Eugene, we can use this using finite element. Okay, what if we are without finite element? Okay, so we have to learn the fundamentals of how to analyze this structure now. Okay, so this structure have an evenly distributed load between point A to point C. The beam has an overhang, right? And you have a pin at point D and a roller at point D. And its task by saying that W250 28.4, okay, so this is W250 28.4. So this beam, this I beam or white flange beam has been selected. So this has been selected. Okay, this has been selected. Okay. So this is the geometry that we know that has been selected, right? So first of all, again, we look at I want to focus on the cross section of the beam. Okay, we want to focus on the cross section of the beam. I want to explain the theory first, what we're going to do. Okay, so I'm going to hold on. I'm going to get I need to get an image of the beam. That's what I'm trying to say. Okay, so I'm going to get an image of the beam. Because I need to draw something. Yes. So the beam is W. So this is C S. I should have done this earlier. Do apologize. Okay, so it's W 250. Okay, it's here. Yep, this is the image that I need. Okay, so this is our I beam. Okay, our I beam. So we know that, right? This is our I beam. We know that we are going to have moment right? And the moment is only in one direction. So we know that we are going to have a. So if I'm going to follow